These are our polynomial graphs notes. So a polynomial, you've worked with polynomials in the past. Polynomial is a blanket umbrella term for binomials that have 2 terms, trinomials that have 3 terms. And once it gets up to 4 terms, you usually just go back to calling it a polynomial. And when I say term, I'm talking about the pieces of our expressions that are separated by plus and minus signs. And so now we're going to look at polynomials as functions. So y equals several of these terms. So I know that sounds overwhelming. So we're going to break it down into some really basics about how these guys graph. So you can see here we have this awesome table. I will mention these notes are long, but it's because I'm giving you lots of examples, or the examples are just like very they're large. They take up a lot of space. So you do have your notes are 3 pages long, but we're going to get through it. It's really not that bad. Anyway, so we start with this table. Our leading coefficient, a, just like in our quadratics where you had y equals ax squared plus bx plus c. All the coefficients all the way to the constant at the end are just in order, a, b, c, d, however many terms you have. So your leading coefficient, a, if it is greater than 0, in an even degree, and we're going to talk more about degrees, but for now, I'm going to refer to it as its exponent. It's not exactly a true statement, but just for simplicity's sake, I'm going to say exponent. If your leading coefficient is greater than 0 and it's even degree, so think about the quadratics. It was x squared. So if I had y equals x squared, it makes just a nice parabola, right? Okay. Well, we're also going to look at what if it's y equals x to the 4th, or y equals x to the 6th, 8th, 10th. What if it's another even degree? It's going to do the same thing. You're going to still have up arrows on both sides. There just might be some extra humps and bumps in between. Yeah, so these are going to get kind of fun. But the point being, if your leading coefficient is positive, if a is greater than 0, and it's even, both arrows will be going up. I'm going to go down to the bottom. If our a is less than 0, so if it's negative, and it's even degree. So let's go back to thinking about our quadratics last week. If it was y equals negative x squared, it was a sad little parabola like this. But what if it's to the 4th or to the 6th or the 8th? What if it's a bigger polynomial that we haven't explored yet? Still going to have both arrows are pointing down. There just might be some extra humps and bumps in between. So notice on the first one, I drew like extra humps and bumps. This one I just did too. So that's going to depend on some other things we're going to talk about later in the notes. For now, let's just think about our ends. So far we've said if a is greater than 0, if a is positive, even degree, both arrows are up. And then we said if a is less than 0 or negative with an even degree, both arrows are down. Now, let me slide over just a little bit. So I make sure I'm not drawing on my video because it doesn't work. If a is greater than 0, but it's odd. So let's say it's y equals x to the 3rd. It's going to have a down arrow on the left, up arrow on the right, and it looks something like this. You've probably seen this guy before. What if it's not just a 3rd? What if it's 5th, a 7th, a 9th, whatever? You're still going to have a down arrow on the left, up arrow on the right. There just might be some extra humps and bumps in between, but it's still going to end in that same way. With what if it's negative? If a is less than 0 or negative and it's odd degree, it's going to start up at the top and go down like that. That's an example of like y equals negative x cubed. You could go on Desmos, graph these, and see that they look like that. And play around with Desmos, it's kind of cool. If it's something bigger, 5th, 7th, something like that, just extra humps and bumps, but finally would end that way. Notice, let me mention this odd degree. It started at the bottom and worked its way up. It increased from left to right. increased from left to right, and this bottom one decreased or went down. Okay? So, recap. If A is greater than 0, even degree, both arrows are up. If it was negative but even, both arrows are down. If the leading coefficient is positive but odd degree, it goes opposite directions, but it's going to go up from left to right, like a positive slope, up from left to right. And then if A is negative but it's odd degree, it's going to go down left to right. And there might be extra humps and bumps along the way. That's just like if your other terms make that happen. You'll see. Use the graph below for the following questions. Is the degree of the polynomial even or odd? So go back up to that table. So we're talking about the degree. So are both arrows the same way? Is even. Opposite ways is odd. So our first example here, both arrows are pointing up. This is an even polynomial. Is the leading coefficient of the polynomial positive or negative? Since both arrows are up, I know the leading coefficient is positive. Number 3, zeros. So we talked about this vocabulary word when we were looking at quadratics. Zeros is another term for those x-intercepts. The zeros are where the graph touches the x-axis. How many zeros are there? Let me switch colors. So anywhere it touches the x-axis, anywhere. Some students will get hyper-focused and they'll just look at the bumps. Sometimes it just kisses the x-axis, so count that too. 1, 2, 3, 4, 5. Number 4, another vocabulary term, relative maximums are any high points. Relative, meaning relative to the points around it, it's going to be a high point. It doesn't have to be the ultimate maximum. It can be any high point. So let me use a different colors for my notes here. Relative maximums, all these high points right there. We can't count the arrows, so just 2 right there. Relative minimums, same idea. Anywhere there's a low point, so there was one here, here, and here. Don't let your eyes skip any of those. There's 3. And relative extremes are both the high and low points. So how many relative extreme values are there? Altogether, there is 5. Just adding all our high and low points together. Wasn't so bad, right? So we're going to do it one more time. Again, these are modeled after your delta math, so you're going to see similar questions there. Use the graph below to answer the following questions. So we're going to do this one more time. The degree, is it even or odd? Here you have opposite arrows going in different directions. So this is an odd degree polynomial. I don't even know what it looks like, but I know it's odd. Is the leading coefficient positive or negative? So I've got, it's going up to down. As I look at it from left to right, it's going down. It's decreasing from left to right. So this is negative. How many zeros are there? Zeros are all the places it crosses the x-axis or touches. I told you it could kiss it. There's 4. Relative maximums. Any high points? 2. Relative minimums. Any low points? There's 1 here, 1 there. Sometimes students overlook the ones that kiss. And then how many relative extreme values are there? That's all of them, high and lows. So just add those up. 4. Any high and low points. Okay. All right, so on to the second page of your notes, talking about in behavior. So you may have noticed where I've pasted the standard. The standard talks about in behavior, and in behavior is kind of a popular topic. It can be tricky for students, but it's not really that bad. Just practice it, and I'll go really slow and explain it here. So in behavior is exactly what it sounds like. It's the behavior of the ends. So it describes what happens to a graph at the extreme ends of the x-axis, to the left and to the right. So if I'm looking at the right side, x approaches infinity, that's to the right, and it's red as x approaches infinity. X approaches negative infinity is to the left, where all your negative values would be, and it's red as x approaches negative infinity. Okay, so thinking about what we just discussed about even positive, even negative. I don't know if the video is going to flip it on me, but this to me is if it's positive odd and negative odd. So sorry if the video is all flopped. Match each function on the left column with a function in the right column that has the same end behavior. So we're going to look at the leading coefficient and the degree if it's even or odd. So for me, I have to take my time on this. Some students, they just like go right through this. Number one is positive in front and has an even. So I know both ends are going up. I'm gonna make a little note to myself. Both of my ends are up and up. So positive, positive. Number two, I have a negative and it's odd. Negative would be going down from left to right. So it should be pointing up on the left side and down on the right side. Number three is a negative even. Both arrows should be down. And number four is positive in front, odd. It should be going up from left to right. So the left arrow should be pointing down. And the right arrow should be pointing up. It should be going up. All right, so let's look at our other column. Switch colors just to be fancy. A, it's positive in front, but odd. So it should be going up, left to right. The left side would be pointing down. The right side would be pointing up. B is positive and even. Everybody's pointing up to the sky. C is negative even. Both are pointing down. And D is negative odd. So it should be going down from left to right. It should be up on the left, down on the right. So there's your kind of like quick check. Some students just see the patterns already, like and matches with B because they're both positive coefficients and even degree. Number two would match with D because they're both negative and odd. So some students go through this really quickly. They don't even think about the end behavior part. Three is C, and that means four should be A. So let's take it a step further. What is the end behavior of the graph? So this is more our speed. This is where we should be. So these are examples modeled after your Delta Math homework. So they give us these lovely graphs. Notice the first example here is odd. I know it's odd because my arrows are going in opposite directions. It's also negative in front because it's going down from left to right. Look at how much I already know. All right, the first statement says as x approaches infinity. As x approaches infinity is the right side. Let me just make a little note here. As I go to the right, what are my y values doing? As I go to the right, my arrow is going down, or y is approaching negative infinity. This is end behavior. You're just saying what's happening at the ends. As this graph goes to the right, it's going down. Let's look at the other one. Switch colors. As x approaches negative infinity, that's the left. As my graph goes to the left, it's going up or towards positive infinity. I do want to say, watch real closely on Delta Math. Something's telling me they flip the order on Delta Math, so read it carefully. Like they might ask, as x approaches negative infinity first. So watch out for that. Something in my brain is telling me that they do that. I think I'm recalling from last year. All right, the second graph I know is even because both arrows are down and it has a negative leading coefficient. So if this was an EOC question or an ACT question and they said which one of these function matches, I already know, look for an even exponent and look for a negative in front. And I could probably narrow it down to just a few answer choices. So these are great test taking skills. Anyway, as x approaches positive infinity, that's the right. As I go to the right, what's happening? I'm going down to negative infinity. As x approaches negative infinity, that's the left. As I go left, we're going down as well, negative infinity. Okay, so that's how you're going to fill those in. If that was too fast, rewind it. Watch it again. To graph polynomials. All right, so we are going to put our hands on graphing some polynomials ourselves. I love doing this. It just takes a little bit of build up to get there. So we need to know the degree. We need to know whether it's positive or negative, and the x-intercepts. So we've already kind of touched about degree. Let's go one step further with degree. We've talked about positive and negative, and you know what x-intercepts are. So this should go pretty quick, and we can start graphing. Sketching. When identifying the degree of a polynomial in factored form, so if I recall correctly, your Delta math assignment will already be in factored form. It doesn't look like x cubed plus x squared plus, it's already in this factored form. Remember, factors are the pieces that were multiplied together. So this is in a nice clean form. If they are in factored form, you just add the exponents on the outside of the parentheses. So you have your basic example right here. This is like what they would have given me. F of x equals quantity x minus 2 times quantity x plus 4 times quantity of x minus 3 squared. Remember, if there isn't an exponent written, the exponent is understood 1. So I've shown you that there. I've added the ones so that you can see to find the degree of a polynomial, you add them all up. So 1 plus 1 plus 2 makes 4. That original example, its degree is 4. Okay. If we had FOILed it out, if we had multiplied all those factors together, our leading coefficient would have had x to the 4th. Don't believe me? Go at it. You multiply it out and you let me know. But it's a 4th degree polynomial. So for that example, I already know it's even. Both arrows are pointing up. I'm assuming that leading coefficient's positive. I already got kind of an idea in my mind what it looks like. Identify the degree of the polynomial when given in factored form. So just practicing this. Number 1, you've got a 2 with an understood 1 plus another 2. This polynomial's degree is 5. Number 2, I've got understood 1, and understood 1. That's a 3, or a 3rd degree polynomial. Example number 3. There's an x in front. That's one of the factors. It just didn't have like a constant with it. So it's got a 1 and a 1 and a 1 and a 1. That's a 4th degree polynomial. Number 4. Number 4, you've got a 3 and a 2 and another understood 1. That's 6th degree polynomial. Okay, so you have to find that degree so you know if it's even, both arrows going the same way, or if it's odd, going opposite directions. So on Jamboard, I had to use another page for the 3rd page of our notes. I mentioned at the beginning of this video that these notes aren't long, although physically they ended up being 3 pages long. But I think it's just we have a lot to cover, basics, and then just practicing each of those skills. So on this next page, to find your x-intercepts, so it said in order to graph them, we needed to know the degree, whether it's positive, negative, and the x-intercepts. So if it's in this factored form, to find the x-intercepts, you set each expression in the parentheses equal to 0, and you would solve it. In other words, it's going to be the opposite of what's inside the parentheses. If I took our example here, this x minus 3 piece, and I set it equal to 0, and I solved it for x, I would add 3 to both sides, and one of my x-intercepts would be positive 3. Or what I'm saying is it's just the opposite of what's in your parentheses. So I know you see a minus 3 there, so one of your x-intercepts is going to be positive 3. The other one's going to be negative 2, and then negative 1 is where this polynomial is crossing or touching the x-axis. Kind of think about the examples we saw earlier, or where I drew like extra humps and bumps. Yeah. All right, so we are going to sketch some polynomials. I really love doing this, if you haven't noticed. Example number 1. You have f of x equals x plus 3 times quantity of x plus 1 times quantity of x minus 4. So we need to know the degree. So we need to add up. Remember, if it's in factored form, add them all up. 1, 2, 3. This is a third degree. This is odd. So my arrows are going to go opposite directions. Now, is it positive or negative? You're just going to look at the very front. If there's nothing there, it's positive. If there's a negative, it's negative. So this is positive. So I know it's odd and it's positive. I know it's going up from left to right. My left arrow should be down. My right arrow should be up. In fact, that's what I like to do. Go ahead and put my arrows. What are the x-intercepts? Well, I'm going to take the opposite of what's in my factors. So it said x plus 3. One of my intercepts is -3. For x plus 1, the intercept is going to be -1. And for x minus 4, the intercept is +4. So I have my end arrows or my end behavior. I know what it's doing. So now you're going to connect them. I know my arrow starts at the bottom. So I need to go through, and up. I don't know how high or low these like bumps and humps are. We're just making a sketch. So think about if you were taking an end of course test or ACT, you could match this really quick with a multiple choice question. Number 2, let's do it again. What's the degree? Remember, if you have a single x sitting out there, he is one of the factors and he has an exponent of 1, 1, and 1. This is a third degree, another odd. Is it positive or negative? It's still positive. And our x-intercepts. Well, let me put my arrows. So it's odd and positive. So again, we're doing like this. My x-intercepts are going to be 0. Remember we said if you take your factors and you set them equal to 0, or it's just the opposite. Well, here's where, remember you set it equal to 0. One of our x-intercepts is 0 because we have that single x out there. Then for x plus 2, I'm going to have a -2. And for x minus 3, I got +3. Now you connect. It starts at the bottom. It goes through and through and through. If you're going through your x-intercepts and you're not ending with your arrows, something's wrong. It should always work. Do it again. Number 3, f of x equals negative quantity of x plus 3 times quantity of x plus 1 times quantity of x minus 2 times quantity of x minus 4. What's the degree? A negative is just a negative. It's just a -1. That's not a factor. We're just focused on the x's and things like that. So we've got a 1, 2, 3, 4th degree polynomial. That's even. Both my arrows are going to go the same direction. Is it positive or negative? There's a big fat negative in front. So both of my arrows are pointing down. I like to go ahead and put my arrows. What are my x-intercepts? That -1 is just a number. It's not an intercept. X plus 3. I'm going to have a -3. I'm going to have a -1, a +2, and a +5. We're going to go through and through and through and through. Number 4. Notice giant, bold, asterisk star, even exponents bounce at the intercept. I have said through and through and through. And also notice in our other examples, all of our exponents on our factors were 1s. This is our first example that has a 2 on it. When we get to that intercept, we're going to bounce. I know, sounds crazy. All right, so what's our degree? We have that 2 plus a 1 and a 1. It's a 4th degree polynomial. Is it positive or negative? Positive. So it's even positive. Both arrows are up. Your x-intercepts. We're going to have a -4. We're going to have a -1. And we're going to have a +2. Okay. Now, keep your eyes peeled because of that even exponent. It could have been a 4. It could have been a 6 or a 2. It's probably going to be a 2 most of the time. On those, you bounce. So we need to bounce where we had a -4. Look at this. I'm going to go down and touch it and bounce away and go through and through. If you do it any other way, you're not going to get your arrows to end in the same way. And that's going to be a clue to you like, oops, I forgot to bounce, or I've done something wrong, or something like that. Even exponents bounce. The rest of them go through. Last two examples. Determine which equation could represent each graph below. Let's see. I'm looking at my end arrows. They are going opposite directions, so I know it's odd. I also know that it is positive, going up from left to right. So far, I don't think I have any winners that have helped me eliminate that. It is crossing right here and right here. Now, oh, but it's bouncing there. It's got to bounce at 2, 4, 6, 8. It's bouncing at positive 8. If it's bouncing at positive 8, the factor would have to be x minus 8 squared. And then this, I'm assuming from my answer choices, is a negative 1. So my factor is going to have to be x plus 1 in order for it to cross at negative 1. Am I making sense? If not, rewind. So let's see. We should have an x plus 1 of these last two, and then I need 2 of the x minus 8s, or that would be quantity of x minus 8 squared. There's 2 of them for it to bounce there. So it's going to be that third answer choice. Let's do it again. See if I can be more clear. You have both arrows pointing up. They're both pointing up, so it's positive. So I know it's even positive. I'm looking at my answer choices. Ooh, this one's odd. 2 plus the 1, that one should be out. And 2 plus the 1, that one should be out. You should have even when you add up all of your exponents. We're bouncing, so both of these factors need to be squared or listed twice, whichever. This one looks like negative 5, so I'm going to have, oh, no, I guess it's negative 3. Sorry, negative 3. So I should have x plus 3 squared because it's bouncing. And this other one is at 6, so x minus 6 squared because it's bouncing. All right, so which one? Minus 6 and the positive 3, this first one. That one right there will match my graphs. I love sketching the polynomials. It is personally my favorite. So here are your polynomial graph notes. Your first page, we talked about just in general, if it's leading coefficient is positive or negative, and if it's an even or odd degree, the shapes that it makes: even, positive, negative, positive, even, positive, negative, positive. And then if it's odd, positive, it's going up from left to right. If it's negative, odd, it's going down left to right. We talked about finding those even, odds, those relative maximums and relative minimums. Those are any high point or any low point. And then the relative extremes is just adding all those together, all your humps and bumps. Matching in behavior, you're just going to state whether it's going to negative infinity or positive infinity. Read those carefully. Like I said, I think Delta Math tries to flip those from time to time, so read your questions carefully. And here's your second page where we were sketching our polynomial graphs and really looking at our factored form closely. So I hope you enjoyed that and followed along. Your Delta Math is going to look very similar. Please let me know if you have any questions. I'll be happy to help you.